Welcome. So thank you for completing the Collaborate board on the relationship between the central and inscribed angle. Some things that I noticed. Well, I remember, first of all, that we learned that central angles are congruent to their arcs. Right, and we can see the central angle is 80 degrees, the one in green, and its arc is 80 degrees. And we also learned that inscribed angles equal half the arc. And we can see that in the diagram. The inscribed angle is 40 degrees. The intercepted arc is this green arc out here. It's 80 degrees. And we can see that if we follow the angle from the vertex to the edge of the circle, we can see that that angle, as best as I can draw it, a little glitchy there, that arc is in between the angle. So what's the relationship between the inscribed and central angle with the same intercepted arc? Well, the central angle equals its arc, and the inscribed angle is half its arc. So therefore, the inscribed angle is also 1/2 the central angle. And that means the central angle, conversely, must be twice, let's put twice, not two, twice the inscribed angle. And we can see that in the measures here, right? So when the central angle is 80, the inscribed angle that has the same arc is 40 degrees, and 40 degrees is half of 80. Conversely, when the inscribed angle is 40 degrees, the central angle that has the same arc is 80 degrees, and 80 is twice 40. All right, so now we've learned some things about the relationship between central and inscribed angles when they share the same arc. So let's complete some notes so that you have that relationship in your notes, and then we're going to solve some problems. And the next page is in your notes, and it's a fill-in. Right, so, and it's all the red words except one, and I'm going to underline the one it's not. So the relationship between central and inscribed angles, and they should say that share an arc, but to understand that it's the ones that share an arc. If an, and so this will fill in, if an inscribed angle and a central angle, and by the way, it's fine to put the symbol for angle, intercept the same arc, you'll have to underline, so inscribed angle is already in there. The inscribed angle is half the measure of the central angle. Next to that, I want you to add that 2 times the inscribed angle equals central angle, just like we did for the arc. Right, 2 times the inscribed angle equals the arc. Or we can write it the other way. Maybe we'll write it the other direction. The central angle is 2 times the inscribed angle. That way we have 2 ways to solve. If we're looking for the central angle, we know the inscribed angle will double. If we're looking for the inscribed angle, and we know the central angle will take half. All right, so here we have a diagram. The diagram's not in your notes. And we have 2 angles. We have an inscribed angle, which is angle ADB. We know it's an inscribed angle because the vertex is on the circle. The sides are formed by chords. and the endpoints of the angle are on the circle. The intercepted arc, so let me write inscribed angle here. Put it here. The intercepted arc is right here in between the endpoints of the angle that are on the circle. So this is the intercepted arc. We see we have a central angle as well. Right? So this was the inscribed angle. Here we have the central angle. We know it's a central angle because the vertex is at the center of the circle. The sides are formed by radii. And of course, the intercepted arc is the arc that's in between the two endpoints of the angle, which is the same as the endpoints of the inscribed angle. So here, since we have an inscribed angle and a central angle that share the same, that intercept the same arc, we know that the central angle, which is angle, the inscribed angle, which is angle ADB. So this is the inscribed angle, is equal to half the measure of angle ACB, the central angle. We could also say that 2 times angle ADB equals angle ACB, because it works the other way. 2 times the inscribed angle equals the central angle. Right? So if you like the diagram and you have a little bit of space or a sticky note, you can always add that to your notes. What you do need to have is the fill-in, right, and a second formula. We have the first formula in the notes. Add the second formula, which is right here. Right? So the fill-in and that part needs to be in your notes. Now let's solve some problems. Not all of them are in your notes. The first one's not. And it's coming up any moment. Here we go. This one's not. We want to find the measure, it should say, of angle COR. We know the measure of angle CAR. That's 48. But we want to find the measure, let me make that a little bit clearer. We want to find the measure of angle COR. All right, so what do we know? Well, we know the measure of angle CAR. We also know the measure of arc CR, although we didn't need to be told that to find the answer to this. Oops, CBCR. And notice that the inscribed angle equals half of the arc. Right, because 48 is half of 96. Or we can think of it the other way. 2 times the inscribed angle equals the arc. Right, and we know that to be true because 2 times 48 does equal 96. We want to find the measure of the central angle. And we have 2 ways we can do that. Right, angle COR. First of all, since we have so much information, we know that the central angle equals the arc. So if the arc is 96 degrees, so is the measure of angle COR. Method 2. we know that the central angle is 2 times the inscribed angle. And that's the one that if it shares the same arc. And these do share the same arc. Both those angles have the endpoint on the circle in the same location. For both of those angles, arc CR is the intercepted arc. So our second method is the central angle is 2 times the inscribed angle. That means angle COR is equal to 2 times 48, which is again 96 degrees. So either way, it's 96 degrees, right? So this one's just kind of an introduction to working with inscribed angles and central angles that share the same arc. Let's solve another problem. I don't think this one's in your notes either. Actually, there's only 2 that are in your notes, 3 that are in your notes. And this one is in the notes. I take that back. This one is in the notes. All right, so name an inscribed angle. All right, so an inscribed angle has its vertex on the circle. There's the vertex. The sides are chords, and if we follow them out, they go to the other side of the circle. All right, so that is our inscribed angle. So you don't have all the questions. Oh, you should have the questions in your notes. I'm sorry. So next to where it says name an inscribed angle, you can name that as angle BAC. We could also call it angle CAB, but we'll just write it one way. Name an arc intercepted by angle BAC. Right? Well, the arc that's intercepted by angle BAC is between the endpoints of the angle, where that angle intercepts the circle. So that would be arc BC. So you can add that to your notes. If the measure of angle BPC is 42, find the measure of angle BAC, and what's the measure of arc BC? So let's solve for this one here. This one here, the measure of angle BAC. So angle BAC. So now angle BAC is the inscribed angle. If you want, you can label that. And this is the central angle right here. Let me use a different color actually. We know it's a central angle because its vertex is at the center of the circle. And we know that the inscribed angle is half the measure of the central angle. So angle BAC is equal to 1/2 the measure of angle BPC. Since angle BPC is 42 degrees, angle BAC is 21 degrees. Do add the complete notes. There's plenty of space to write everything in. If you don't write everything in, you go back to look at your notes, they won't make sense to you, right? It's like skipping steps in a recipe. How'd you go from this step to this step? What's all the in-between stuff, right? It'll be too confusing to follow. And what's the measure of arc BC? Well, we know that central angles equal their arc, so we won't have to show any work really on this one. So arc BC is the same measure as angle BPC. So that's 42 degrees. Right? And so this one is done. Right, so you should have all the things that I added into your notes. If you can't squeeze in inscribed angle and central angle, it's all right to leave it out. But it would be good if you could squeeze it in. I understand everyone has the same size handwriting, but the rest needs to be there. All right, let's solve the next one. I think I've got 4 more. You've got 2 more in your notes, so maybe I'll only have 3 more. So this one is the next one. This one is in the notes. So I think maybe there's just 2 more. All right, so we want to find the measure of x. All right, so x is an inscribed angle. And we know the inscribed angle equals half the central angle. And this is the formula we'd want to use because we're solving for the inscribed angle. We want that one isolated. So that means x is equal to half of 50, or 25 degrees. So that's not much notes. You can certainly squeeze that one in. There's lots of space there. Right, and I think this one might be the last one. Now this one is the most involved one. You definitely need to write in all this information, right? Because we'll need to justify our answer on this one as soon as our page turns. All right, so here, and this might be a very common one you might find on a test. All right, and you have the notes above, early on the top of your notes, right in the middle of the page there. So if an inscribed angle and an essential angle intercept the same arc, the inscribed angle is half the measure of the central angle, right? So just a reminder there. All right, so now we may not be able to directly be able to solve x, but we can work our way through this problem. The first thing I notice is I have a central angle here. I don't know the measure of the central angle. I don't know the measure of the intercepted arc. But I do remember that central angles are formed by radii. So this one is a radius, and this one is a radius of our circle. It goes from center to the edge. And I remember something about radii. All right, so add this part to your notes. First of all radii of a circle are congruent. That's the first thing I notice. Right? You can write above and below that diagram. All right, so that means that these two are congruent to one another. Now I remember, so notice this forms a triangle. You've got the two radii, and then you've got this chord here that connects those points. And I notice that that's a triangle. And I remember something about, so it has two sides congruent. I know that's an isosceles triangle, and I remember something about isosceles triangles. I remember something called base angle theorem. And that is angles, and I'll abbreviate, in a triangle, opposite congruent sides are congruent. Add that part to your notes. So now I know that this angle here and this angle here are congruent. That means that this one must be 50, so you can label that angle as 50. And finally, next, I remember something else about the angles of the triangle. I remember something called triangle sum theorem. And that the angles in a triangle add to 180 degrees. By the way, if you ever run out of space, then you can always add a sticky note. And if you're in class, I got sticky notes. All right, so now we know we can find the measure of that central angle. So that means that, let's call this, we don't want to use x because we've got an x there. Let's just call this y. And why? Why not? So y plus 50 adds to 180. That means y plus 100 adds to 180. If we subtract 100 from both sides, that leaves 80 for y. Actually, this is a good one for a sticky note. You can have the diagram underneath and all the steps above. So now we know what this one is. We know this y here is 80 degrees. Now we can think about the relationship between the inscribed angle and the central angle. So that means x here is 1/2 of 80, right? And that's because the inscribed angle, I'll kind of abbreviate, equals half the central angle. You can leave this part off if you want, because it's in your notes already above on the page there. So that means that x is 40 degrees. And there we've solved it. All right? So notice we worked our way through from what we know. Just once, I want that bell not to be on my videos. So we worked our way through what we know, right? The fact that we know that a central angle is formed by radii, and that gave us the congruent sides. And then we remembered base angle theorem, so that gave us the congruent angles. Triangle sum theorem gave us the measure of the central angle, and then we used the fact that the inscribed angle is half the central angle. So have this in your notes. You can always attach a different sheet of paper too, and I can take your book apart and bind those pieces of paper as well. I think that's my last problem, so I'm going to stop. And I can pause in class on this problem, or if you're watching it in the student paced version, you can pause. And if I see a blank screen, I know I'm done. That means I'm done. So I'll just put this page back. Thanks for watching. And in the next video, we're going to look more at a type of inscribed angles. So bye for now.